Hey guys, welcome back again. Math 135. This is section 2.6, the second to last section of chapter 2. Skipping the intro today, we're going straight to the learning objectives. Number 1, find the possible number of positive and negative real zeros of a polynomial. And that's just basically applying Descartes' rule of signs, which we'll talk about in this video. Then second objective, find the bounds on the real zeros, so upper and lower bounds. That's going to be using this rule here, the theorem on bounds. And then 3 and 4 we're doing together. Learn some basic facts about complex zeros of polynomials and then use the conjugate pairs theorem. Now all these terms, don't worry if these are unfamiliar to you because we're going to learn about them as we go along. Starting with number 1, finding the possible number of positive and negative real zeros. Okay, so that's applying Descartes' rule of signs. Descartes, that name might sound familiar to you. He's a super famous mathy guy. He's the guy that came up with the Cartesian coordinate system, right? We named the Cartesian coordinate system after him, x and y axis, all that. Okay, so given a polynomial p of x, the rule of sign says, first, determine the number of changes in sign of that original p of x. So in other words, you look at your polynomial, you arrange it in decreasing order like we usually do, standard form, right? And then you count. How many times does it switch signs from like being positive to negative or negative to positive? So let's say you have like 5 sign changes, okay? So the second part says the number of positive real zeros of the original polynomial is equal to that number or less by some even number. So like let's say we counted 5 sign changes. That means there must be 5 positive roots, 5 positive real zeros, or 3 or 1. Those are the only possibilities. Okay, the second half of the Descartes' rule of signs says to determine the number of sign changes of p of negative x. So you take your original polynomial, you plug in negative x, you rewrite the thing, and then you again count the number of sign changes. And then that's going to say the number of negative real zeros is equal to that same number or less by an even number. So kind of same thing. So let's say you counted three sign changes when you plugged in negative x. Then that must mean there's 3 negative roots or 1 negative root. Or let's say you counted 2, then there's 2 or 0. Those are the possibilities. Okay, this is kind of, in math or in general, when you're learning things, you kind of divide the things that you learn into 2 categories. Things that are like facts that you kind of just memorize versus things that you try to kind of understand conceptually or have some intuition behind. To me, this was more of like a fact territory. So when you have something that's a fact, it's a good idea to kind of just think of some mnemonic to help you to memorize the thing. This is kind of based off, this idea is based off something I learned before a long time about how you learn things. There's a great video called Study Less, Study Smart by this psychologist guy. I recommend checking that video out if you have time. Just search it on YouTube. So the psychologist goes over how to learn things without overstudying and how to use some tricks to use your brain to learn well. Okay, so here's my stupid mnemonic, and please don't laugh. I think you guys should actually come up with your own. This is just an example, but here's how I remember this thing. So I have these 2 little acronyms, like PSCH, positive sign changes, positive P for positive, S for sign, CH for changes. So the number of positive sign changes is the number of positive roots minus 2, 4, 6, 8, 10, or some other even number. And then you're like if it's the other way, then you say the number of negative sign changes is the number of negative roots or minus 2, 4, 6, 8, 10. Okay, I know, super mnemonic. Like I said, recommend you think of your own, but this is just an example. Okay, let's try out question number 1 and 2. We're gonna go straight into those in this video right now. So numbers 1 and 2, determine the number of possible positive and negative real zeros. And we're restricting ourselves to real zeros right now. We haven't talked about complex numbers yet. We're going to talk about those in a future video in this section. Okay, let's do number 1 and 2 though. Okay, so first of all, number 1, we're going to count the sign changes in this thing for the original f of x, in this case, p of x, whatever. It's just a different name. So this one starts off positive, right? That 2 x cubed, that's a positive term. Still positive. Here you switch to negative, right? So that's the first sign change, 1 sign change. And then from that negative to positive 2, that's another sign change. So 2 sign changes. two sign changes of the original f of x. Means either 2 or 0 positive zeros. Now the other half to that is, what if I do f of negative x? So to do that one, I have to rewrite this function f of negative x. What happens if I plug in negative x? X cubed is going to become negative 2x cubed. If it's positive, if it's even power, you keep the sign as it is when you plug in a negative. And if it's odd power, like x or x cubed or x to the fifth, then you switch it. So it's going to be plus x plus 2, right? So now we're going to go and count the sign changes here. Okay, from this is a negative term to a positive term. So that's one sign change right there. And this is positive to positive to positive, so only one. Which means there can only be one negative 0. Now this is kind of something powerful here because it tells you for sure you have a real valued 0, a real valued negative 0. 0 is not a possibility because if you subtract 2 from 1, that's a negative number. You can't have negative number of zeros, right? So either I have 2 or 0 positive zeros that are real, but for sure I have exactly one negative 0. Later on we'll talk about what's the other possibility. If it's not 2 real zeros, what happens? Well, you might have complex zeros. So that was number 1. Okay, number 2. Pretty easy, right? Number 1 and 2, very easy questions actually. Just applying that rule right away. Okay, number 2, you got f of x equals to that whole thing. Let's count our number of sign changes. So here's negative to positive. So I got our first sign change. From positive to negative, second sign change. And then here, negative, negative. Negative 2, the last term is positive. That's our third sign change. So three positive sign changes. Right? Three of those guys. And then that means 3 or 1 positive root. Okay, when I say positive sign change, I mean if you plug in positive x into your original function, right? It's your original function. Now what about f of negative x? That would be positive 5x to the fifth minus 3x to the third minus 2x to the squared plus 7x and plus 4. Okay, so now we're going to count the number of sign changes here. Let's use a different color. How about red? Okay, so here's a positive term to a negative term. So that's one sign change. Negative, and then negative to positive, that's 2 sign changes. So 2 sign changes, right? So this is a so I have either 2 or 0 negative roots. Okay, right now all of those are possibilities. We don't know anything else about the polynomial. So 3 is a possibility, 1 is a possibility, 2 or 0, those are all possibilities for the number of roots. Okay, and that is question number 1 and 2. Let's see, shall we talk about theorem on bounds? Let's see. Let's save that for the next video.